In Algebra 1, we spent a lot of time on linear equations. As a matter of fact, we came back and revisited it in Algebra 2 because it's really just that important. So, in order to graph linear equations, you need to know some particular information about them. Now, a lot of you are probably looking at this going, well, at this point in time, wouldn't I just plug it in the graphing calculator and graph it? Probably you would, and that's fine. There's one small issue with the graphing calculator, which is in order to graph this, you have to put this equation in slope-intercept form. And it's not in slope-intercept form. It's in something called standard form. Standard form, depending on what textbook you're using, is often written as ax plus by equals c, or sometimes it's written as ax plus by plus c equals 0. Either way, standard form is a linear equation where your input and output, x and y, are both on the same side of the equal sign. So first, we're going to go back to slope-intercept form. Slope-intercept form was y equals mx plus b. In order to put this equation in slope-intercept form, you have to subtract 3x from both sides, and you have to subtract 2 from both sides. So now you're left with negative 4y is equal to negative 3x minus 2. And now, to get rid of the negative 4, you have to divide everything by negative 4. Oops. So you're left with y is equal to positive 3/4 x plus 1/2. That means the y-intercept is 1/2 and the slope of the line is 3/4. Now, remember that the slope of the line gives you an idea of what the line looks like. So if you graph it wrong, hopefully you should be looking at the slope going, should my line look like that? What am I talking about? Well, anytime you have an equation where the slope is positive, the line should go up from left to right, which is the case with this particular equation. When we do graph it, it better go up from left to right. If the slope is negative, the line will go down from left to right. What happens, though, if you have an equation where the slope is 0? That is your constant function. It's a horizontal line. It should always be parallel to the x-axis. And then the last thing that can happen is you can have something called undefined slope. That means you have an equation that actually does not have a slope. Those equations are vertical. And again, we say that the slope is undefined. Okay, so what if I wanted to graph this by hand? This is not a good problem to graph by hand because the y-intercept is 1/2. However, this is what I would do. I would start at 1/2, which is going to be right there on the coordinate plane. And then a slope of 3/4 says to go up 3 and to the right 4. So again, look at where my green dot is. To go up 3 to the right 4, I would go 1, 2, 3 to the right. I'm sorry, that's 3 up. And 1, 2, 3, 4 to the right. And then I put a big old dot. And then I would do it at least one more time, although in geometry, we learned that 2 points determine a line. So you actually only need 2 dots on the graph to draw the line between them, but I don't know about you, I'm anal retentive. I like to make my line as exact as humanly possible, so 1, 2, 3 up, and 1, 2, 3, 4 to the right. And then I put a big old dot, and then here would be my line. Okay, so there are a couple other things we want to do with this line other than just graph it. Again, once you get the equation here in slope-intercept form, you can use your graphing calculator to graph it. But sometimes there's some other information that we want to determine, like what are the x and y intercepts? Remember, the intercepts are the locations or ordered pairs where the graph crosses the axes. So the x-intercept would be where the graph crosses the x-axis, and the y-intercept is where it crosses the y-intercept. When you have an equation in slope-intercept form, so we had determined this was y equals 3/4 x plus 1/2, this is the y-intercept. The y-intercept is at the location 0, 1/2, because the x-coordinate is 0. But because of the way I drew this, if you're looking at this going, well, the x-intercept's at -1, is it? It's not. All right, so I'm going to use a different color here. I'm going to go back to the original equation. The original equation here was 3x minus 4y plus 2. 3x minus 4y plus 2 equals 0. The x-intercept is the location where the y-coordinate in the ordered pair is going to be 0. So if you plug in 0 for y, it makes that negative 4y go away. And so you're left with this equation, and you find out that it hits the x-axis at -2/3 or -2/3, 0. I could have done the same thing to find the y-intercept even if I hadn't put it in slope-intercept form. If I had wanted to find the y-intercept from the original equation, I would have replaced the x with a 0. If you replace x with 0, 3 times 0 is 0, you're left with -4y plus 2 equals 0. So -4y is equal to -2, y is equal to +1/2, and that's where I would have found the y-intercept from. Finding the x-intercept is also known as finding the 0. The 0 of a function is the location where the y-coordinate or the output is 0. So again, finding an x-intercept is the same as finding the 0. And there are some other words we used for this too later on, but we're going to start with that for now. In pre-calculus, we are always worrying in linear equations about the rate of change between two values. We call the rate of change a slope. Well, in Algebra 1, you learned slope as, first of all, you called it m, and you probably learned it as y2 minus y1 over x2 minus x1. And the only way that you could find the slope was if you knew two ordered pairs that lie on the same line. Well, in pre-calculus, we also call this delta y over delta x. This is the Greek letter delta. I know, you're looking at it going, triangle. That's the Greek letter delta. And in mathematics, delta means change or subtraction. So for the purposes of pre-calculus, I want to look at rate of change, the application of the slope formula. So here in example 2, archaeologists use bones and other artifacts found in historical sites to study culture. One analysis they perform is to use a function to determine the height of a person from a tibia bone. Typically, a man whose tibia is 38.5 centimeters long is 173 centimeters tall. A man with a 44.125 centimeter tibia is 188 centimeters tall. Write two ordered pairs that represent the function. Well, unless this is a problem involving years, which it's not, I normally write the ordered pair based off of how I read the problem. So I might make the first ordered pair 38.5, 173. So this would be like my length of the tibia, and then this would be my height, and everything's in centimeters. My second ordered pair would be 44.125, and the other coordinate would be 188. Now the reason I said that the exception is year is because normally if you have a year, it's normally going to be your input. So if you have a problem that involves years, you would normally make that your x coordinate. Now, we've got these two ordered pairs. I want to find the rate of change through the 2 points. I want to find the slope. So the slope is going to be y2 minus y1 over x2 minus x1. So I've got 15 over 5.625, which is approximately 2.67. Now, what does slope mean in this context? One of the things we're going to focus on this year whenever we run across a problem involving rate of change is what does the rate of change mean? So if your teachers haven't focused on it, you do need to focus on it. What the rate of change in this particular problem says is that for each 1 centimeter increase, now where did I get that from? When I reduce that fraction, it's really 2.67 over 1. It says that the change in the size of the tibia is 6 centimeters for each 1 centimeter of the man's tibia. So if you add another centimeter to the tibia, his height increases by 2.67 centimeters, approximately. That's the meaning of the slope in this context. And that is what you need to focus on from section 1.3 on graphing linear equations.